Podcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to the AREA's webinar, The Challenges of Enterprise AR Implementation and How Industry Leaders Overcome Them. Please feel free to ask questions via the question box, and they'll be answered at the end of the webinar. If time does not allow our experts to answer all the questions, we'll respond with an answer via email. Thank you and enjoy.
Okay, thank you, Amanda. And hello, everybody. My name is Mark Sage, and I'm the Executive Director of the Augmented Reality for Enterprise Alliance, or known as the AREA. And a warm welcome to our latest webinar, The Challenges of Enterprise AR Implementation and How Industry Leaders Overcome Them. The AREA has delivered a number of webinars, which can be found at our new AREA website, www.thearea.org. And if you navigate to the AREA resources and the AREA videos and webinars, you'll be able to find previous webinars. And there's lots of other information about enterprise AR available on the AREA portal. So I, would like take the opportunity to go and have a look at that, and you can also find these webinars on our YouTube channel as well. Okay, so let's get on with our webinar today. I'm really excited to be joined by some of the world's leading experts and practitioners in enterprise augmented reality. Panelists are responsible for delivering AR solutions within their organization and are able to talk in detail about their experiences in implementing AR solutions. Hope you are looking forward as much as I am to listening to their insights and some of their experience. So just before we start, I'd like to give you a quick overview and introduction about the AREA Alliance and the work that we are doing. So the AREA is the only global membership-funded alliance helping to accelerate the adoption of enterprise AR by creating a comprehensive ecosystem. The alliance was formed after a number of innovative companies began speaking regularly and found that they had started or wanted to invest in enterprise AR. By working together, they created a better understanding of what enterprise AR tools are available, what can be done, the methods of implementation, and started to really understand the return on investment that's available from AR. This led to opportunities to co-innovate, to build partnerships and business opportunities, all for the goal of the long-term adoption of AR technology. So today, the AREA offers a free and open exchange of good practice, lessons learned, and technology insights, which is helping enterprises effectively implement AR and helping AR providers engage with enterprises as well. The AREA membership comprises of enterprises, AR providers, and non-commercial organizations, which you can see on this slide. We are focused on helping supporting the adoption and growth of the enterprise AR ecosystem. I call the current ecosystem irregular. Enterprise AR is still in its infancy, so there are still some questions about which areas to invest in, what are the best use cases. Finding enterprise customers is still a long sales process for providers. However, and it's really fair to say, we are moving very rapidly towards a developing or developed ecosystem. And our panel today will highlight some of the best use cases and what they've been working on. It's clear that enterprises are beginning to understand the performance and efficiency gains from AR, and business decision makers like the CEOs, CTOs, and CIOs are getting involved in AR conversations, so it's a really exciting time. Finally, a quick overview of the initiatives the AREA is working on to help the enterprise AR ecosystem. We deliver thought leadership content by creating, collecting, and curating the latest neutral content about AR enterprise from thought leaders and experts. The AREA offers networking opportunities, both from virtual meetings and face-to-face events. It's a great way to engage with the members and the wider ecosystems, to build partnerships and to co-innovate and discuss what needs to be done to drive the enterprise AR ecosystem forward. The AREA is really focusing on reducing barriers to adoption, and we have created a number of committees and working groups including research and safety, requirements and marketing. And at the moment, the members are looking to set up a security committee as well. The area research capability enables members to create research proposals, which the members then vote on. We have recently delivered the first member-exclusive comprehensive research reports focusing on security in wearables. This research has benefited many players, especially enterprises considering using wearables, and the research was very well received by the members. The second research project is focusing on creating an enterprise AR ROI, return on investment calculator, and supporting reports. This should be finished by the end of the year and will provide a much needed thought leadership content for enterprises who need to understand and report on the potential ROI that AR can bring. In March, the area and UI Labs hosted the first enterprise AR functional requirements meeting. Based on work from Lockheed Martin, Procter & Gamble, and Caterpillar, the area now owns a set of requirements that will be shared with the ecosystems for both hardware and software, and that will help enterprises create RFPs, requirement specifications, and allow AR providers to define their roadmaps and map against the requirements. Another barrier to enterprise AR adoption is the potential safety issues when using AR. The area members have recognized this and created a safety committee to focus on understanding, documenting, sharing, and developing recommendations and solutions for AR safety concerns. Finally, we understand there's a industry or the potential for an industry skills gap. So we're looking to define AR courses, both technical and business, with universities, research institutes, and other such organizations, so to ensure that we have skills needed for the future. Okay, so I hope you've learned a little bit more about the area. If you're interested in finding out more and how it may benefit your organization, please feel free to contact me on mark@thearea.org. Okay, let's get on with the webinar today. As I said, I'm very excited to have panelists here. I'm just going to introduce each one very quickly, and then they're going to go into a little bit more detail about what they're doing in the AR space. So, Brian, would you just like to introduce yourself quickly?
Sure. So I'm Dr. Brian Laughlin, a PhD in human factor psychology. I'm a technical fellow and an IT architect for the Boeing company. I've been with Boeing for, gosh, going on 25 years now. I started when I was about 6 years old, so I'm actually a lot younger than you might think.
Thank you, Brian.
I'm a certified sheet metal composites mechanic. I've done planning, I've done tool coordination, just about everything.
Excellent. Thank you, Brian. And Jürgen.
Hello, my name is Jürgen Lomera. I'm in charge of product management around augmented reality for Bosch internal and external use, and have driven the foundation with other people, the foundation of ARIA. So I will give more input when I'm showing my company slides.
Yep. Thank you, Jürgen. And Lauren, are you with us? Okay, I think Lauren's just joined in. She should be with us within 1 second. So what we'll do, if it's okay, we'll move on to, so Brian and with the rest of the panel can explain a little bit more detail about what their companies are doing in the AR space. So Brian, if I can hand over to you to talk about your work at Boeing. Brian, you're still on mute.
Sorry about that. At Boeing, we're using augmented reality in a large range of different areas. Everything from training type applications to work instruction delivery to design and engineering, prototyping, and those kinds of things. As you can imagine, we have over 160,000 people around the world, and we have a lot of different products that we develop. And we probably are one of the largest, if not the largest company in terms of the span of reach. We do everything from the depths of the ocean to the farthest reaches of space in terms of the kind of work that we do. So there's a broad field that we cover. Some of the things that we do in particular, you'll see these pictures here. The upper left-hand corner, we have the satellite solar panels in space. They're actually using a Vuzix app device there to inspect solar panels. As you can imagine, these solar panels is kind of a one-shot deal. If you don't have these things absolutely perfect when you put these things up in space, you can't send the Maytag repairman, figuratively, to go up and take care of that problem. So it's absolutely critical that we have these things spot on and there are no issues with them. So the way that they used to have to do this particular job is they would have to go and mark these things with tape, and they had kind of a bingo type, a grid paper that they would have to mark these defects on and then record them in triplicate in different locations. And so trying to find that same location, and it can be a hairline fissure in one of these solar panels, and it's not acceptable. So it made it really difficult to try to figure out, where these things were, and to go back to that and shift changes and things like that. With augmented reality and informed reality, we can actually go and locate those and guide the people, the inspectors and stuff, directly to where the discrepant area is, so they can be repaired very easily. To the right side there, we have GenCode. We're actually building out an OS and device agnostic backbone in that case to help to deliver point of use and time of need and work instructions for mechanics and whatnot on the flight lines. So we found that it was actually in a Boeing Frontiers article that an AOG on average cost our airline customers between $10,000 and upwards of $150,000 an hour, which is a tremendous amount of money. So shaving seconds off of the turn times for these airplanes is absolutely critical. And by developing this OS and device agnostic backbone, we'll be able to plug in tablets, headsets, and any other kind of wearables or an AR type device in conjunction with being able to connect to things like cloud computing, data analytics, additive manufacturing, to enable us to bring the power of each of these respective siloed technologies to bear in a more cohesive systems type approach. Project Blackwell, we actually do some work.
Brian, sorry, this is Mark. We're having a few problems hearing you, so I don't know if you can. If we just move on to the other guys, you may be able to dial in by
command and control type work.
Okay, we're just losing Brian a little bit there, so we'll come back to Brian. I'm going to move on now to Jürgen to talk a little bit about Bosch.
I just want to. Yeah, can you hear me?
Yep, can hear
clearly?
you.
Okay, perfect.
Right.
I think you can switch to the next slide already, because my intention here is to really give an overview what Bosch is, because most of you may even ask yourself, why is Bosch interested in AR and what they are doing and what part you're talking to. And Bosch is a huge company. I mean, we have close to 400,000 employees. We have 440 subsidiaries, smaller companies. We have around 73 billion euros revenue. We spend a tremendous amount in R&D, so 7 billion euros. We have 120 engineering locations worldwide, and we do quite a significant EBIT through all of this. I mean, there are additional numbers on the left side, but the focus is it's a company who really is worldwide engaged and has a lot of employees. And on the next slide, we see the 4 categories in which these all are separated. It's the mobility solutions, which I'm from, and I will give you on the next slide more. That is the industrial technology. It's really manufacturing, IoT, Industry 4.0, plant equipment, hydraulic, energy and building technology. It's heating systems and whatever you can imagine, security systems and consumer goods, and drilling machines. but also white goods, and so you see we have a very wide variety of applications. All of them are interested in what we do in the mobility solution. So we provide things to all of them internally. But the mobility solutions, of course, our main focus, and all of my questions and all my answers to the questions will be around mobility solutions. When you go to the next slide, please. And what is mobility solutions? I mean, it's the largest part in Bosch. Really, I think we make close to 38 billion euros revenue. And it's really about connectivity, urbanization, but the demographic trends what we implement around energy. But important is, you see on the bottom, it's around automotive. Electrical vehicles, autonomous driving, e-mobility, driver assistance system, head-mounted, the human-machine interface, head-mounted displays, but for drivers, and you see quite a lot of things, including Internet of Things. But all of that, whatever we do, augmented reality is in one way or the other involved in. Not directly, like when you say a driver assistance system, it's obvious it would be involved, but automated mobility or automated parking, you have many applications of augmented reality around those. On the next slide, I even go farther to more concrete applications where I say, okay, what do we focus on? So because I'm even out of a specific part where we focus on optimizing training, service, repair, etc. So we see augmented reality as the most efficient way to deliver any type of information, any. It really doesn't matter which one, if it's for training, for sales, for production, or whatever. And why we are doing this? Why is Bosch even thinking we need to do this? Because we realize in our own and on our customer product that's an increasing complexity. We have pretty high cost of training and retraining and limit knowledge retention. We know experts who needed to create all of this in the past, and we needed solutions for mass data creation. So all of the stuff Mark said, why we founded ARIA, address these problems. And very often we ask, why is then Bosch even involved in this? Why is Bosch doing this? Because we're not just selling software, we're selling solutions, and we understand how to apply it, because we have internally a huge base or huge applications. In the center you see a car, and we implement the majority of our solutions around making the service technicians more efficient. And we have around 38,000 workshops, which either belong to Bosch or belong to Bosch as in a franchise way. But all of these are users of augmented reality, can be improved efficiency, etc. So therefore, it's applicable to Bosch and customer products. And customer for us means we're selling this to OEs, we're selling this to production plants, to whoever needs a support by delivering information. And our overarching goal, whatever we implement, is always we want to make a technician more efficient by improving the information delivery. And maybe in the future we even don't name this anymore augmented reality. Important is that somebody gets faster information displayed at the time when he needs it. I think I'm done.
Thank you very much, Jürgen. Okay, Lauren, have you been able to join us?
Yeah, can you hear me?
Yep, can hear you. So,
oh, perfect. Okay, so sorry, I missed the introduction. My name is Lauren Hamburg. I'm the technical lead for business development here at Newport News Shipbuilding. We are the sole provider of nuclear-powered aircraft carriers for the States and one of two providers for nuclear-powered submarines. We've got about 20,000 people that work here. And if you're unfamiliar with what an aircraft carrier is, it's basically a floating city that you can only fuel every couple of decades. So with a minimal amount of maintenance every few years, that city's got to function. So it's got everything from barbershops to airports to nuclear reactors. So all of that has to work, and we build all of that here in Newport News, Virginia. As far as augmented reality goes, we've been doing it for over 6 years. Again, we cross all different disciplines, much like the rest of the shipyard. So we've got every flavor of engineer, mechanical, electrical, nuclear, industrial systems. I myself am a math major, so we've got the sciences covered. We've got finance majors working, so we take people that wouldn't traditionally create augmented reality applications, and we turn them into augmented reality engineers. We leverage heavily off of our designers to create a usable 3D product model for us. We designed the ship, the next 4 class carriers, all in 3D, and we leverage off that same talent to create our models that we use in our applications. Like slide size, our emphasis is on cost reduction, not just monetary cost, but also schedule cost, resource cost, any kind of reduction. We've got over 75 large-scale projects ongoing or completed inside, and a few outside commercial customers that we've been working with over the past few years. And among our group, we do have our company, the augmented reality team, is a dedicated group to creating augmented reality applications. So nobody here works in this group as a collateral duty or a good idea. We have over 35 people in the group, again, from designers, engineers, software developers. We do have some separate divisions inside the group, so we do have a dedicated R&D arm. And they're really investigating and benchmarking head-mounted displays and a lot of the IoT platforms and services that are coming out. And that's what we do.
Okay, thank you very much, Lauren. And thank you very much, everybody. Brian, just checking that you're back online, and can you just say hello?
Hello, I'm here.
Okay, great. Okay, so everybody, we're going to just go through a set of questions now, really just trying to pull out some examples and to try and give everyone a bit more information from the panelists. So the first question I'd like to pose, and this is to Brian to start with, very high level, but what business problems have Boeing and you've seen being solved by using AR? If you can give us some examples, that would really help.
Sure. So there's a number of business problems that lend themselves well to the AR space. One of them that we really have a big problem with is Boeing is a very large place. In the Everett factory, for example, it's over 13 million cubic feet. That building is the largest free-span building in the world right now. And so in order for these employees often to do their jobs, these airplanes are massive. They're very, very big. And so a lot of times the information and the places, they have to go all over the place to collect information. And they usually have to do some amount of research before they get to actually touch the airplane. They have to collect things like PSPS specs and what their work instructions are and all these different kinds of things. So they have to amass this kind of an information kit, if you will, before they can ever begin to do work on the plane. And often that can take, on average, from around 10 minutes to sometimes upwards of 2 hours, depending on the complexity. And in a worst case scenarios, it can take longer than that, because it's absolutely critical that they have everything they need and that they do exactly the right operations in order to build this plane correctly. So as you can imagine, that it's very costly to have those problems. And one of the big things that we're doing is using augmented reality to help the mechanics actually have information that they need at the point of use and time of need. And so they can actually go to the location of work and have the AR device step them step by step through work instructions and be able to call on help if they need it. They can get remote assistance from an engineer or from a shop lead or from a QA inspector. They can buy off on jobs as they complete them at the location. So there's a bunch of help in terms of AR, what it can provide in actual manufacturing environment. Another strong place that we're using AR is in the design world. We do a lot of things with space, International Space Station, return to Mars, deep space habitat missions, things like that. And so as you can imagine on a spacecraft, the space on that spacecraft is at an ultra premium. And it's critical that we understand how things are going to fit onto that spacecraft. And in the case of the space station in particular, these different parts of the spacecraft, if you will, that might need to be replaced or repaired have to actually fit through the apertures of the spacecraft. And so one of the things that we've been able to do with AR is to be able to 3D print, do a combination of augmented reality and additive manufacturing to 3D print parts and then test them out at scale using a augmented reality or virtual reality type environment, a mixed reality environment. So that's been very effective. A third place that we use AR is helping folks to train new mechanics and pilots. So as you can imagine, with the aging workforce, there's actually a dramatic decrease in the talent that we're going to need to fly these airplanes and to repair them. And training is very costly, and it's hard to, there's no real return on investment until later. So it's something you pay for up front and there's no immediate return. So we found that we can actually shave a lot of expense out of the cost of training both pilots and mechanics by using a mix of augmented and virtual reality, depending on the case, to facilitate those areas.
Great, thank you very much, Brian. That's very insightful. Jürgen, how about the work at Bosch?
As indicated, we're focusing at the moment in that area to make a service technician in the workshop more efficient. And why do I need this? At the moment, the vehicles are already pretty complex. So they are already pretty individual. So if I get as a service technician in the workshop, I get a vehicle, I need to repair it, and the first thing I need to do, I connect the diagnostic system to it. And then the system tells me where to look for certain components, how to do certain activities. They have already challenges with this. And they already have to transfer information which they read on a standard tablet or PC to the vehicle. But this will tremendously increase right now because you get new type of engines, electrical engines, hybrid vehicles. You will have self-driving cars at different levels from 3 to 5. So a service technician in the workshop needs support to deal with this increased complexity. And what we're doing is really we want to support him to get the best possible information to fix a given problem, to find the location in the car, despite the fact that each vehicle is pretty much individual. You get 3 vehicles nowadays into your service bay, and they all look different because everybody had a couple of options they ordered, and therefore it's different. This component is here, the other is there. I don't have this when I have a hybrid. I don't have a tank with it, etc., etc. So our business problems we are solving is to give a service technician the best possible set of information despite an increased complexity, and at the same time a reduced training availability or training environment.
Okay, thank you, Jürgen. And Lauren, how about problems you solving?
Yeah, so our biggest problem really is getting information to the deck plate. Right now with two-dimensional drawings, it's incredibly cumbersome. Our shipyard is about a mile long, and different components and different things are made in different places. And so unlike, not to take away from the complexity of my fellow panelists, but, you know, for us to grow and get a drawing and take it down to the space that we're going to be working in that day isn't just walking across a room or even a lab or a hangar. It's, you know, across an entire shipyard, and then you have to carry it up, you know, several ladders if you're working above deck or below deck, and it's just very complex. So one of the really powerful things about augmented reality is now we actually have a way to leverage off of all this 3D data that we have and deliver it to the deck plate in a 3D mode. So we don't need these long 100-page drawings anymore. And when I say drawing, if you've never seen an industrial drawing, it's not, you know, an 8 by 11 sheet or just a couple sheets. It's, you know, 3 or 4 feet long, 100 pages deep, and there's nothing, the drawings typically don't say, here's the drawing for exactly what you're working on today. A piece of what you're working on is across several drawings. And so it's incredibly difficult to locate that information and translate it into the work you're actually doing. So that's one of the key areas that we're using augmented reality to address. Another one is like everybody else says, the training and the time it takes to get people up to speed. We are a high variability, low rate production operation. It takes 7 years to build an aircraft carrier. So we have inspections that we run once every 7 years, and it's easy to lose a lot of that that knowledge from inspection to inspection. So we can leverage again off of augmented reality and take that training out of it. So people who are doing these once every 7 year inspections or once every 2 or 3 year inspections, they can have easy access. A lot of these aren't complex inspections or operations. It's just a fact of learning how to do it and recognizing, oh, okay, this is what we're actually trying to do here. We're looking for something that's not there in a lot of cases. So we can use AR to train people in that space while they're trying to do it. We don't need a schoolhouse. We don't need separate training. We don't have to wait for different divisions to become available. We can just give them the application and they can go straight to the deck plate and get to work. So those are the two really key areas that we're using AR.
Okay, thank you, Lauren. And it's kind of interesting how we've gone from land to space to sea, across all the different parts of the universe. But some business problems are similar, some are slightly different. So it's kind of an interesting go through them all. The second kind of question is to focus a little bit more on benefits. There's potential here, but always already realizing some benefits. So perhaps I can ask the panelists to get a little bit more specific on the benefits and hopefully a little bit more tangible. So, and if it's okay, I'm going to start off with Jürgen and within Bosch. Can you talk a bit about the benefits that you're realizing in a bit more detail, please?
Okay, the benefits in multiple areas, and I think the best example is that we can measure the improvement even with simple implementations. So typically we implement more complex cases where we show installations, animations, superimposed via glasses or tablets. But we wanted to know how our service technicians in our own workshop would use a technology like that. And even if we support them with only component location, no animation, no real repair procedures, etc. And what we figured out, that first, independent of the age, they all love that technology. And they all saved time. And they saved, in average, 5 minutes per task. And the task in the workshop can be a total sometimes of 20, 50 minutes. But in average, they save 5 minutes out of their task. It's in average 15% of their time can be saved if they use augmented reality for location of components. And why is this? Because we used even a vehicle, it's a Golf 7, in Europe very common, and we had expected that most of the service technicians would have already experience with that car. But they only have experience with configurations who come along very often. But we use certain features which are not in each Golf. And they used it, and they were really, really tremendously better, and that helped them to get familiar even with unknown configurations, etc. So we really see the benefit to bring very fast knowledge to our technicians by applying even in very simple things augmented reality. Then we have the other case. This is an application we developed for Daimler where you deploy solutions for the first responders. So we developed this together with first responders. We enable them to be faster accessing somebody is stuck in his crashed vehicle without hurting the first responders. So the efficiency increase in this one is really obvious. Even if they save 1 minute to get you faster out of the car, it's worth it. And even they use it just for training to be faster than when they don't use it on a crash car it is. So it's another example. It's a real world example, and everybody maybe get involved. When you drive a Mercedes and you have an accident, most likely the first responder has an app and has been trained with augmented reality to be faster finding components and get you faster out of that car. Components are uncrashed airbags, high voltage wires, etc. But it's the same. Basically, we help somebody to find the right information in a critical situation, given the high variations. I think that's the difference between a Boeing or a Newport Shipbuilding. You have very complex, large vehicles, and we have smaller vehicles, and tremendous variations, and we need to address this to it. So maybe there's even combination. I don't know if it's good enough that you also have, of course, high variations in yours, but I guess not so many as we have, because you have millions of vehicles, and each vehicle technically could be totally different. So we see this as significant benefit of AR, increasing the time or reducing the time somebody needs to locate certain objects, and therefore the service technicians gets much more efficient, significantly more efficient.
Thank you, Jürgen, and certainly, AR being used to save lives is a huge benefit, and any time saved is going to help. So yeah, that's really insightful. Thank you, Lauren. Perhaps I can ask you to talk about the benefits that have been realizing and looking for in the future.
Sure. I think we could probably have an entire webinar on this very topic, but I'll try and keep it short. One of the biggest benefits we potentially see is mobility, and not just mobility in the fact that, yes, you can carry AR with you, but also moving the classroom essentially from a schoolhouse or an office or a classroom onto the deck plate, onto the ship. You can do training. You don't need to create mock-ups. You don't need to create, drawing representations of things, of systems you're going to be training on. You can actually walk out to the deck plate, to the ship, and you can keep, everything in context and relevant to what you're doing. So for example, watertight door inspections that we do on the ship, there's over 54 types of watertight doors on a ship. They all look similar. None of them say what type of door they are, but they all require a very specific type of maintenance done to them. But there's different nuances between the different types of doors. And one of the biggest problems is actually identifying the type of door. So there's really no amount of classroom training that can address all 54 or so types of watertight doors on the ship. But what you can do is you can create the application to say, okay, I'm in this compartment, what type of door am I looking at? And it can bring up that training and that maintenance item, which can be the same application. It can bring that up to them while they're on the deck plate. Again, eliminating the need for a schoolhouse or a classroom for this specific instance. Obviously, there's certain cases that you want people, training on mock-ups or things in the classroom, but there are a lot of cases where it's just not necessary. So it's kind of rethinking how you're going to be training sailors or any kind of user in the future, because AR can give you that ability to do that in the space and on the system that you're actually going to be working on. So that's one of the really big benefits. The other one is, again, that reduction in training time, that you don't have to teach people how to read drawings. I can look at a 3D object and on my application, whether it's a heads-up display or a tablet, and I know what I'm looking at. But right now, we deliver all the information in manuals and two-dimensional drawings with different views, and that training is really detailed. It's very in-depth. It takes people a long time. So being able to just deliver that information, again, keeping it, maintaining that scale and perspective of the object in the real world, so you don't have to stretch your brain at all to say, okay, this is what it looks like at a 10th scale, and now this is what it looks like full size. AR can address all of those things. So those are two of the areas that we're really seeing big benefits from AR.
Okay, thank you, Lauren. And Brian?
Yeah, so kind of building on what Lauren was talking about, we both, our companies build very massive products, and it's tough. They're very complex. They have a lot of parts into these different things. So one of the very incredible applications of AR where it really shines that we found is in the use of really complex tasks like plumbing or wiring, for example. If you can imagine these mechanics and electricians and whatnot, they have to actually go out and look. We take a 3D drawing and then we convert it to a 2D or a 3D model, and we convert it to a 2D drawing in the form of a blueprint or drawings for the mechanics to use as reference, which is kind of ridiculous. And then they have to take that 2-dimensional drawing and then convert that back to 3 dimensions to actually do the installation or do the work that they're trying to accomplish. And so as you can imagine, it's very wasteful, and it's also really confusing when you have a very noisy environment. One of the things that we found that's really helpful is, since the time we were drawing in the dirt with a stick to the time that you're looking at your 4K tablet or a Google Glass, not using augmented reality, the process is exactly the same for consuming information from a cognitive perspective. We look at the information, we take notice of the salient aspects of that, basically take some kind of a mental snapshot of it, do some transformations in our head, and then we project that onto the workspace that we're working in. So whatever's left from all those mental gymnastics we have to do is the bandwidth that you have to actually go and solve the problem, which is why you're there in the first place. And by the way, maintaining all this information in our mind, we're not really very good at it. Our working memories are very fleeting. Your iconic memory lasts for a few milliseconds. Your echoic memory, meaning your auditory loop, which is a lot of times what we do is rehearse information that we're trying to remember. Think about trying to remember a phone number so you can dial it on your phone. It lasts a few seconds. So it's this losing battle. We're not very good at these things. We can eliminate all that by taking the digital asset and sticking it directly on top of the as-is condition in the real world. And not only that, the asset is dimensioned. So we can tell what the differences are in terms of size. And by looking at the object from different perspectives, we can see how well it's going to fit. And even better than the real world, we can change the translucence of the object so I can see through the object to look at the interfacing features, between these different parts. So it actually, in some ways, it turns us, it kind of makes us bionic in a way, or superhuman capabilities, and it plays to our strengths, which are, from a cognitive perspective, the ability to compare and contrast different things that are very similar versus trying to rehearse and maintain a lot of things in memory. So we found it to be super powerful in really complex tasks, again, like wiring and plumbing, for that reason. It helps you to do a better job the first time. We found up to a 90% increase, actually over a 90% increase in first pass yield. So quality is kind of the root of everything for us. And if you don't do it right the first time, then you incur cost and time and all these other things. We've also seen about a 30% consistent average decrease in time, and this is based on studies that we did at the University of Iowa with a simple kind of a constructive bench task. So super powerful results from AR.
Thank you, Brian. And yeah, again, very insightful. So let's go on to the third question and ask, obviously, you superheroes, as Brian's outlined. So it's great to hear about what you have been doing and some of the benefits, but there are obviously some challenges. So can you perhaps talk about the biggest challenges and how you were able to overcome them as an organization? Perhaps Lauren, I could start with you with that question, please.
Sure. This is probably another one that we could have a dedicated webinar on. Part of for us, a lot of it has been flexibility, has been one of the biggest challenges. There are so many potential devices, there are so many potential operating systems, there are, so many different environments that we're working in. Some might be good for heads-up displays, some might be good for a tablet, some might be better on a cell phone. What kind of cell phone, what kind of heads-up display, all of these things, maintaining that flexibility or being ready to accept that flexibility into a typically not very flexible environment like the shipyard is a monster challenge. That there's early on people were like, oh well, we need to pick we need to pick a device. We need to pick a device, and that needs to be the AR device. And we fought back on that one because we knew, even early on, There were some things that were better on an iPad. There were some things that were better on an Android. There were, at the time, there were no heads-up displays really, except for Google Glass, which was not great for us. And as time goes on, it's not, it's not that there's fewer things out in the market now, that now there's more. Now there's different kinds of cell phones, and they all come with their own operating systems. And there's Linux cell phones, and there's pros and cons to everything. There's tethered heads-up displays. There's wireless heads-up displays. There's and each of those have their own good and bad. HoloLens is great, but has that limited field of view, and Meta is great, but it's tethered, so it's difficult for me to put that on a welder who's working on a propeller, standing 6-7 feet up in the air. So having the infrastructure in place to be platform agnostic, to be iOS agnostic, to be device agnostic, to be ready to evaluate each situation on its merits. So we don't become too attached. Early on it was all iPads because that was, all we could do with Unity. But there were issues there too. Our iPads don't have a good security system like the Knox container does for Samsung now. So we couldn't develop on our network using, our nuclear propulsion information. But then as things went on and the shipyard finally let cameras in VR and let smartphones in VR and nailed down that our corporate phones going to be Samsung devices using the Knox container, we were able to shift. But having that infrastructure in place to be able to easily translate all these different things, all these great use cases, and that, some use cases aren't really great on a heads-up display, and some are pretty terrible on a tablet, and some are really great on a cell phone, but aren't good on others. So I think the biggest implementation challenge is, convincing people to invest in, 100 iPads and then convincing them, a year down the line that we're going to move to something else in a different situation. So that's kind of been one of our biggest implementation challenges. And the best way to overcome that is just internal PR, really, to say, hey guys, roll with it. Here are the benefits to what to the things that we're doing. So all of these items really just become consumables. Don't, you see this price tag. I know it's a little bit scary, but it's going to be saving us so much money on the other end from, pre-planning and post-analysis that the cost of the device isn't changing, just is going to be kind of a non-issue. So we're starting to come over that hurdle.
Yeah, thanks, Lauren. And I think, some of the work that the area is doing on interoperability and, creating kind of a standard set of requirements and things like that can help some of those problems for the future. So it's slightly easier to move from different platforms and devices and, make sure you get the best for the solution that you need. Okay, Brian, can I ask you the same question and get a view from Boeing, please?
Absolutely. And again, because I think our industries are similar, I'm going to pile on to what Lauren was saying. I think she hit a lot of really good points. Interestingly, I think at the core of a lot of this stuff, though, she talked about how, the churn of technology, how what's great today is replaced tomorrow very quickly by something that has more advanced features, and that kind of this focus on cost instead of benefit. A lot of times we look at cost and we say, gosh, that thing costs so much. Well, for example, what does defibrillator cost? Well, they're very expensive. Well, but what's the value of saving somebody's life? Well, it's priceless, So I think we have to look at what is the value and quit looking so much at cost and start to think about these things not as assets. We tend to think about things as physical assets, and so we get upset when a computer costs a certain amount of money instead of thinking about what it actually is, which is a service. It enables us to do a particular thing. Nobody who ever bought a drill wanted a drill, they needed a hole. And so that's one of the things I think I battle a lot in kind of thinking through, listening to Lauren and whatnot, is we have a lot of issues about managing expectations and helping people to think correctly about what technologies have to offer. In accord with that, because we work in critical areas, military, so a lot of it's very secretive, and you can't necessarily have camera-enabled devices in particular areas. It's an issue that we have to address. The other thing is a lot of the stuff is, our engineering is our crown jewels, and so we have to protect that. And a lot of these new devices, the biggest, the most the biggest attack vector. So for example, like the Target breach, what happened with that is an HVAC company came in, they were doing work on Target, and the attack that they had where they lost all that private information actually happened through the HVAC system, and then they got into the credit card system, and that's how they took over the Target, hacked the Target system. So we have to think about each of these different devices as we add them into our environments as a new attack vector, and what are the different ways that these things could breach our security and actually steal our intellectual property in the form of our drawings and engineering. So that's another really big area, is making sure that we secure things adequately. Another area that we have to address, or I have to often address, is this kind of magical sense of technology, again with the expectation management thing. Folks a lot of times have this kind of a fairy dust and unicorn, sense of technology. If only I had an iPad, a HoloLens, insert your favorite technology, life would magically be better. And what they don't see is that there's a lot of upfront work that goes in to the proper implementation of these things in the form of homework and kind of knowing what your core why is. What's the soul of the intention that you're trying to accomplish with this device? And then go and build the best business practice possible, cleaning all the waste and stuff out of it. And then and only then do you turn to technology to control, accelerate, or distribute the information processes. And if you don't understand that, then you're doomed to being really upset because you think that just simply buying this technology is going to save the day. And you're going to be disappointed. It's not going to give you the kind of benefits you'd expected because, again, the expectations were not managed correctly.
Okay, thank you, Brian. And Jürgen.
I would say there are three areas which currently really stopping AR to be successful deployed in augmented in enterprises. At least in the type of enterprises we're dealing with, we have a lot of variations. Your engineering data is not ready. But there are tools right now to really scale and really deploy larger applications. But typically, the engineering data is not ready directly for the service, because they design a vehicle, they do certain things, and you cannot transfer. There is some modifications necessary, there is certain things, and this costs you, independent of if you're using AR or not. The data is not in a state you can directly use it. You have to process it in a certain way. I'm not talking about making AR out of it. It's metadata, things nobody thought ever before, that I need to align 3D objects now much tighter with service information, with training material, etc., because there was no need before. So all of this is coming. The second one is the hardware devices in the workshops. There is not in all workshops worldwide already tablets with cameras. They have tablets, they're using diagnostic system, but not all of them have cameras. And if I don't have a camera device inside, I don't use AR. So first I need to get also a strategy around how do I deploy new augmented reality devices or augmented reality ready devices. And not all of the OEMs or all of the bigger companies are bring your own device ready, which would maybe solve stuff like that. And the third thing, and I think we see this more and more, and when I say states like that, it's not just Bosch's view, because we provide this as a supplier to our customers and use it internally. So we know both worlds very well. And one big thing is you can use AR for so many use cases. And very often everybody tries to find the best use case. And, oh, I could use it here. Is it better there? Is it better? And nobody makes a decision. It's really diluted where you can use it, instead of saying I focus on area A or B or C because I expect to get the biggest bang here, and then I have my light tower project, and then I deploy more. And to get this is really hindering larger deployments. And I'm sure everybody has this discussion internally, where it's the best use. I have an idea here, a department comes there, do something, and we need to get over this to really deploy it in a way that everybody benefits from.
Yeah, thank you, Jürgen. I'd like to echo that last point. It's, my work within the area, it's very much asking organizations or trying to understand what the key use cases are, and that can be from where they get the most benefit, or potentially they're kind of first and easy steps into AR, so they begin to understand. So it's really important to be very clear on the best use cases, and then to measure the work that you do. And this is something we're also working on within the area about return on investment and best practice for that. So yeah, I'd like to echo some of those some points made by Jürgen. Okay, so we're getting pretty close to the top of the hour here, and I want to just have a bit of time for some questions. So the attendees, feel free to type in some questions. As I said, we will, if we don't get a chance to go through them all, which I don't think we will certainly respond to them. So if I can ask the panelists, we're coming to the last question, and I'm sorry, it's a big question. I'm going to ask you to try and cover it quite quickly, but what are you planning for the future for AR? What do you think it will mean to your business? So yeah, the crystal ball time, and Brian, perhaps if I can start with you and Boeing's view of that.
So from my perspective, the future of AR, first of all, the devices, as you notice, they're getting smaller and lighter and more powerful. Today, probably some of the state-of-the-art technology is in the form of the wearables like daiquiri and HoloLens and things like that. The next phase, and you're going to see this like with Magic Leap, you're going to have waveguide technology where you're actually beaming the photons directly into the eye, which is going to mean a much lighter headset that you'll be able to wear. And the next step beyond that is going to be actually non-invasive intercepting and beaming of the information directly into your brain. There's been some studies at, I think it was University of Irvine, California, where, if I'm not mistaken, no, I take it back, I think it's UCLA. At any rate, that what they were able to do was intercept the signals from the eyeball going into the brain, and they were able to tell that a guy was looking at a picture of a parrot, and they're able to run it through an algorithm and reconstruct it, and it looks like a very blurry vision of what he actually looked at. So a little bit scary, but super powerful, and this stuff is moving quickly. The other thing is, I think for the future of AR, that it's not going to be about AR. It won't be about cloud computing or data analytics or additive manufacturing or IoT. It's going to be not an either or, it's going to be an also and. So it's going to be a systems type approach where all these things become conversant, and the human will just become simply another node on the network in the Internet of Things. And so all these things will be conversant, and we'll be able to actively turn computers from being kind of a dumb tool to proactively assisting folks at the point of use in the time of need with pertinent, timely, and accurate information.
Thank you, Brian. Jürgen, can I ask you the same question, please?
Well, I think it's very simple. For us, augmented reality will be the main interface for a service technician in the future. And what I mean by that is, it's really, imagine he's wearing glasses, and all of the devices at the moment in a workshop which have individual displays he has to walk to, or at the vehicle information coming out, all of this will be superimposed or aggregated in one single device. So for Bosch, augmented reality is the future interface of workshop technicians, and of course in a wider sense for anybody consuming technical information and needs aggregation of multiple sources, not just traditional information, anything producing data. So IoT brought to glasses.
Thank you. Yep, and I'm sure we will get there. Lauren, just your good self as well. What do you see the future?
Yeah, just real quick, really just to combine what Brian and Jürgen said, it really, we think that AR is going to kind of be that interface to IoT, period. So no matter who you're delivering it to, or no matter what type of information you're delivering, it's going to come through an augmented reality interface. It's going to be overlaid in the real world, and that's just the way it's going to be.
The way it's going to be, yeah. Thank you. Okay, I think we've got time for just one or two really quick questions. There's a really great one from Patrick Johnson, and it talks about the deployment of large-scale AR projects within your organization. So, how big are they, or are they kind of proof of concept pilot phase? Perhaps, Lauren, I'll start with you quickly on that one. Can you just give an insight of the size of the projects that's happening at Newport?
Yep, I can definitely take that. We've got all types. So we have large-scale projects that are very much large-scale and span, entire systems on a submarine, from about from the end of the front. I can't think right now. But so we have very large-scale projects. But we also have lots of proof of concept. We've got, I have targeted the entire top side of the submarine. So we collect all that data. We report it out the results at the end. But then we also have, lots of one-offs where a couple we did in just for, maybe less than 10 compartments, and there's thousands of compartments on a ship. So we'll do a subset and then, prove it out. And then we're still working on scaling all of those up. But again, like I said before, a lot of our some of our bigger, larger scale applications happen once every few years. So there's really no scaling up in those instances. We do the inspection that one time and then wait the next the iteration for it to come around. So it's all sizes.
Okay. Yeah, and again, that's probably my experience of speaking to, I've worked out over 400 companies, be it enterprises or providers of AR solutions, and there's a mixture. We're not it's deployed as much as we'd like to in terms of large scale projects, but certainly there's bigger projects and smaller projects and proof of concept. So, that kind of fits with them. Brian, I'm just going to ask you a quick one. This is from Willard Williams. How do you manage the transition from complex engineering drawings into various devices in a usable format? I know this is something that, with your background, got an insight into.
Sure. So that's a really good question. For example, if we take the CATIA drawings, CATIA drawings are very large. They are massive files. And so how do you put that on a HoloLens when a HoloLens can handle upwards of possibly 5 million polys? We find that 2 million or less is kind of where it's more happy at. You get too many polys and it starts getting jittery and you have all kinds of anomalies that are not conducive to what you're trying to do. So we actually have a decimation process that we go through, and that's been a really big part of our journey using AR, specifically with HoloLens, is how do you find out, what is that happy medium? What is enough in terms of resolution on a particular image? One thing that's interesting about AR versus VR is they're nearly diametrically opposed. With VR, it's immersive, and so I want to take your reality and I want to replace it with my own version of it, and I really want you to buy into my version of it. So it's really critical that I have really high resolution imagery and that the frame rates and all that stuff are spot on, because otherwise you induce sickness and things like that. With augmented reality, because your frame of reference is the real world, you don't tend to have those same issues that you have with VR. So you need to shift your attention not from how high the resolution is, and in fact that can actually get in the way. What the mechanics tend to prefer is more of a ghosted type image. So you go lighter in terms of how many polys and the resolution, and you focus more on the interaction with the particular objects, if that makes sense. So that's one of the things that you have to kind of pay attention to. And I think it really comes down to really understanding what is the application, what's the best device, to deliver that, and then custom make, your imagery to fit that. The good thing is it doesn't mean you have to have a separate kind of image for every single thing, but it does mean you need to have probably a couple different categories depending on the use, if that makes sense. So again, higher res for VR, lower res, for AR, like HoloLens, for example. And then if you're using tablets and that kind of stuff, a lot of times it's somewhere in between there, if that makes sense.
Great. Thank you very much, Brian. And I think we've come to the end of the webinar. I just want to firstly thank the listeners out there. I hope you found it useful and insightful. I certainly did. My special thanks to the panelists, to Brian, Jürgen, and Lauren, for able to share some of their insights. This has been recorded, so we'll get it up onto the area website and YouTube channel, so you can go through it again. And again, if anybody is interested in this space and want to help develop the enterprise AR ecosystem, or want to find out more, please feel free to contact me. So thank you very much, and hopefully we'll see you again or hear you again in our next webinar, and I wish you all a very pleasant rest of your day. Thanks, everybody.
Thanks for organizing this.
Thank you.
Thanks, guys.
Have a great week.